Good morning, everyone. Today I am going to start a new lecture for you people. Here in this lecture, I will try to explain actually what is inversible matrices. Inversible matrices, that means in case of matrix for the first time you have got inversible actually. You have got the idea about inversible in case of real numbers, in case of sets, in case of functions, in everywhere you have got the idea about inverse. Okay. So the same concept will be applicable here also, but here in place of the real numbers, in place of the functions, we will apply matrices. So let me recall first actually what is the meaning of inverse, or under what condition we will get the inverse. If I ask you in case of real number, what is the inverse of 2, then what will be your answer? Then obviously your answer will be half, or you can say that minus 2 is the inverse. Remember, 2 has two different inverse. Depending upon the operation that you want to apply, inverse will be different. If I am discussing about a multiplication operation, then half is known as the inverse. If I have discussed about the addition operation, then minus 2 will be the inverse. Then under what condition we can say that half is the inverse of 2 under multiplication operation and minus 2 is the inverse of 2 under addition operation. So what is the similarities among them? What is the property satisfied by them to have the inverse actually? What is the answer? What will be the answer? 0. I think you have the idea about that 1 is known as the multiplicative identity. 1 is known as the identity element for multiplication operation. That means if we multiply 1 with any real number, that element will be remain same. 0 is known as the identity element for addition operation. That's why 0 is known as additive identity. That means if we add 0 with any number, that element will be remain same. If we multiply two numbers, operation should be multiplication. If we multiply two numbers, after having the multiplication, if you are getting the identity element of that operation, যদি এই অপারেশনটো আইডেন্টিটি এলিমেন্টটো পোৱা তেতিয়াহ'লে one of them is known as the inverse of the other. এটা এটা কামটো ইনভার্স বুলি কোৱা হয়। সিমিলারলি দুটা নাম্বার প্লাস কৰিলে যদি অপারেশনটো নাম কি এডিশন অপারেশন, এই অপারেশনটোৰ আইডেন্টিটি এলিমেন্টটো যদি গুচি আহে তেতিয়াহ'লে তাহাঁতৰ এটা ইনভার্স বুলি কোৱা হয়। তাৰমানে দুটা এলিমেন্টৰ ইনভার্স হ'বলৈ হ'লে অপারেশনটো কৰাৰ পাছত আফটাৰ হেডিং দ্য অপারেশন ইউ শুড গেট দ্য আইডেন্টিটি এলিমেন্ট অফ দ্যাট অপারেশন। সেইকাৰণে আমি আকবাৰ ৰিকল কৰি দিছো। If we multiply two elements after having the multiplication, if you are getting the identity element, then it will be known as the inverse of each other. 2 is the inverse of half is the inverse of multiply inverse of 2. Similarly for the function, আমি জানো দুটা ফাংশনৰ কম্পোজিট যদি আইডেন্টিটি হয়, ফাংশন হয় কাৰণে আইডেন্টিটি ফাংশন আমি ইউজ কৰিছো। I is the identity function. Then G is known as the inverse of F is known as the inverse of G. তোমালোকৰ মনত আছে কি জানিবলৈ লাগে মানে ফাংশন কোফিচিয়েন্ট। That means here also we can say that half into 2. Same. F not G, G not F. In both the cases, if the result is an identity function, then they are known as inverse of each other. In the same way, over matrix of vector, if the multiplication of two matrix is equal to an identity matrix, দুটা matrixৰ multiplication of the identity matrix হয় AB as well as it should be BN. Both the conditions should be satisfied. তাৰমানে ইয়াত matrix multiplication in general commutative নহয়, it is non-commutative. That means to have the identity element, to have the inverse, this should be commutative. AB আৰু BN দুইটাৰ ভিতৰত কিমান হ'ব লাগিব multiply কৰিলে identity matrix পাব লাগিব. Identity matrix means what? Whose diagonal elements are 1. This one is the identity matrix of order 2 by 2. So identity matrix and এটা কথাটো হ'ল আইডেন্টিটি ম্যাট্রিক্স সিস্টেম ইজ এ স্কয়ার ম্যাট্রিক্স। তোমালোকে জানানে কমুটেটিভ প্ৰপাৰ্টি, দুটা ম্যাট্ৰিক্সে কমুটেটিভ প্ৰপাৰ্টি স্যাটিসফাই কৰিবৰ কাৰণে দা অৰ্ডাৰ অফ বোথ দা ম্যাট্ৰিক্স শুড বি স্কয়াৰ ম্যাট্ৰিক্স এণ্ড অৰ্ডাৰ সেম। দুটা ম্যাট্ৰিক্স স্কয়াৰ ম্যাট্ৰিক্স হোৱাৰ উপৰিও অৰ্ডাৰ সেম হ'ব লাগিব, দেন দে উইল বি কমুটেটিভ। অৰ্ডাৰ শুড বি সেম, both of them should be square matrix. আৰু যদি এই square matrix ৰ resultant identity matrix পাবা, it will be of same order. For example, A is a matrix of order 3 by 3, B is a matrix of order 3 by 3. A number of column is equal to number of row, and after having the multiplication, what will be the order of the new matrix? 3 by 3. Obviously. Here also it will be what? 3 by 3. It will be what? 3 by 3. So number of row is equal to number of column. Number of column is equal to number of row. Then we can easily multiply. Multiplication exists. After having the multiplication, what will be the order in new matrix? 3 by 3. That means আমি কম যে if A and B are square matrix of the same order, then commutative will be exist. And our regular matrix or commutativity হয় এইবিলাকৰ ক্ষেত্ৰত আমি ইনভাৰ্স কৰিব পাৰোঁ। এতিয়া চোৱা simple কে মই আপোনাক কৰিছো। Whenever a multiplication of two matrices is an identity matrix, then one of them is known as the inverse of the other. Okay, that means দুটা matrix of multiplication multiply কৰিলে কি পাব লাগিব? Identity matrix পাব লাগিব, and they should be commutative also. Then again 2 into half is equal to 1 is equal to what? Half into 1. Then again equation similarly it should be equal to b. Okay, so let me define first. My definition the word is okay. মনে রাখিবা suppose খালি মনে রাখিবা দুটা matrix of multiplication value যদি identity হইছে, one of them is known as the inverse of the other, but they should be commutative also. AB should be exist with BA. BA are ready to exist কৰিব লাগিব. Okay, so let me write down a definition of inversible matrix. মই যদি কওঁ suppose A is inversible. Inversible. What does it mean actually? There exists a matrix B. A matrix inversible মানে এনেকটা matrix B আছে যাৰ লগত A টো multiply কৰিলে you will get an identity matrix. মই যদি কওঁ suppose C is an inversible matrix. What does it mean actually? C is an inversible matrix means what? There exists a matrix suppose B such that after having the multiplication B with C will get an identity matrix. Okay. So what is the definition of inversible matrix? I am going to write it down. If A is a square matrix if A is a square matrix of order n, remember in case of square matrix means what? Number of rows equal to number of column. That's why whenever you try to mention the order of the square matrix, you have to mention only one symbol, either n. That means number of rows equal to number of column. That's why we will try to write down A is square matrix of order n. Okay? If A is square matrix of order n, and if there exists another square matrix B of same order M such that what is the condition to be satisfied? AB should be equal with BA should be equal with I. That means their multiplication should be an identity matrix. Then the matrix B, then B is said to be the inverse matrix of it. Inverse of A and is denoted by A inverse. Just go for definition once again. So suppose A is a square matrix. First of all, we have to consider to have the inverse. First of all, the matrix should be অকল আমি এটা গম্বলি square matrix of inverse থাকে. In square matrix of order n, generally order to equal to number of rows and number of columns should be mentioned. But in case of the square matrix, number of rows is equal to number of column always. That's why it is always mentioned by symbol only. If there exists another matrix B of the same order, remember that to have the inverse, the matrix should be a square matrix. If A is a square matrix and at the same moment, if there is another matrix B of the same order, such that their multiplication AB is equal to what? BA, that is they are commutative, and what is the result of the multiplication of two matrices is nothing but an identity matrix. Then B is said to be the inverse of the matrix A. যেটা আমি যেটো নতুন ম্যাট্রিক্স আমি কনসিডার করেছিল সেই ম্যাট্রিক্সটো एक्चुअली n নামৰ ম্যাট্ৰিক্সটো ইনভার্স হয়, and is generally represented by A inverse. So what is the main criteria to be satisfied? Full-bilang matrix or inverse exist করিব? Obviously square matrix or inverse exist করে. But the matrix should be of the same order. So rectangular matrix or Q inverse exists no kore because in case of rectangular matrix AB is not equal to BA. Rectangular matrix or because AB or BA only property satisfy no kore. Okay, I think you have got my point. So let us consider one very simple example for you people. Suppose it will be better for us actually to have the idea. Suppose A is a matrix of order 2 by 2, 2, 3, 1, 2, and B is the matrix whose elements are 2, minus 3, minus 1, 2. This is an order of 2 by 2, and this one is an order of 2 by 2. Now we try to find out the value of AB. As number of column is equal to number of rows, so we can say multiply A and B. So what will be the order of a new matrix? It will be of 2 by 2. Just try to multiply. First row. What is the first element? A11. That means first row, first column. First row, first row. Just try to multiply. So what will be the procedure? 2 to the 4 minus 3. First element. Then what is the position? First row, second column. First row, second column. Actually, কি হ'ব লাগে? First row, first column কৰিলো. Then first row, second column কৰিম. So 2 minus 3 will be minus 6 plus 6. Okay. Then in the second element you have to second row, first column. 2 1. Second row, first column is second row, first column. 2 1 the 2 minus 2. 2 minus 2, and second row, second column, it will be minus 3 plus 4. So what is the answer? We have got, it will be 1 0 0 1. This is nothing but an identity matrix of order. That means after having the multiplication of AB, we have got an identity matrix. That means we can say that probability is there, the matrix B is the inverse of A or A is the inverse of B. Let us try to find out. That means we have to say BA also. Both the conditions satisfy AB as well as BA should be equal to an identity matrix. Let us try to find out the value of BA. What will happen? So BA, obviously BA also exists because they are of same order. So after having the multiplication BA, first of all we will consider these elements. A11, first row, first column. Rows should be from the first matrix and column from the second matrix. First row, first column. Just multiply. 2 to the 4 minus 3. 2 minus first row, first column, sorry, to the 4 minus 3. Then first row, second column. First row, second column, 6 minus 6. Then second row, first column, minus 2 plus 2. Minus 2 plus 2. And second row, second column, minus 3 plus 4. Exactly, we have got 1 0 0 1. This is nothing but an identity matrix of order 2. As AB is equal to BA is equal to I, therefore B is the inverse of A as well as A is the inverse of B. I think you have got my point. What is actually inversible matrix? To have the inversible, the matrix should be of square order, square matrix hobo lagibo. And if A is a matrix of order 2 by 2, then B is also a matrix of order 2 by 2. That means eta matrix or zero order thake ta inverse matrix to order hole same thakibo. Under what condition we can say that they are inversible? Because their product AB is equal to always BA and is always equal to an identity matrix. Then we can say that one of them is the inverse of the other. So very important topic from your NCERT textbook. So in the next video we'll try to explain one question: how can you find out the inverse of any matrix? Okay, thank you so much for watching the video.